Hey y'all, and welcome back. Today we're going to be talking about quadrilaterals and how we name some of the special types of quadrilaterals. Quadrilaterals, remember, are any closed shape with four sides. So for example, this is a quadrilateral. It has four sides and is closed up. But this is also a quadrilateral. And that one looks a lot more familiar. There's a square. In order to talk about all the quadrilaterals that we have, because there are so many types, we give them special names on the inside. Instead of just saying quadrilaterals in general, sometimes we want to talk about a special type of quadrilateral. Those special types of quadrilaterals are parallelograms, trapezoids, rectangles and rhombuses, and the most special kind of quadrilateral is a square, because the square is the regular version of a quadrilateral. Let's talk a little bit more specifically about each one of these terms, and then we're going to draw in a graphic organizer that will help us to see the relationship between these terms. The first term that we need to know is we need to know parallelograms. So, by far, the most common type of special quadrilateral is a parallelogram. And we can see the word in here that's going to help us to understand what's happening there. A parallelogram has exactly two sets of parallel sides. So if you're taking notes, you're going to write in that it has two sets of parallel sides. Let's see what that looks like. The standard parallelogram will look something like this. It looks kind of like a rectangle that started to tip over. What is happening is that those sides are parallel. Remember, parallel means they go on forever without ever touching, as opposed to intersecting where they cross, or perpendicular where they make a perfect X or a perfect corner. Parallel means they never touch, not intersecting, not perpendicular. So parallel sides are sides that would go on forever. And I'm not a very good artist, so I draw it in there, and when I draw it in there, I often mess up. We can tell that this is actually a curving line, but it shouldn't be. So the way that mathematicians, and especially I, will mark to show that are parallel is to say, these sides will never touch. Not only that, but these two sides will also never touch. We use these symbols to say, like an arrow, it goes on forever without touching. If I were to draw it out, so if I were to imagine drawing this one out, and I were to imagine drawing this one out, they shouldn't ever touch. Let's draw another parallelogram, so that way you can see a different way of them looking. They could be looking like this. They could look like this. They can look all sorts of different ways, as long as the two sides never touch. Both of these sides have to never touch. I have to have two sets of parallel sides. That's a parallelogram. Now, inside parallelograms, we have special types. Inside parallelograms, these are special types of parallelograms. Just like a parallelogram was a special type of quadrilateral, we have special types of parallelograms on the inside. The one you'll be most familiar with is a rectangle. And the word that will help us to remember what makes a rectangle special is in the word, rectangle. It's a parallelogram with four right angles. So all of its angles are the same. In a rectangle, all of its angles are the same. And you're very familiar with how rectangles look. There's a rectangle, and you can see all of these angles are 90 degrees. This is also a rectangle. All of its angles are 90 degrees. That would be a rectangle. The other special kind of parallelogram is something called a rhombus. A rhombus is a special type of parallelogram. It's a parallelogram where instead of like a rectangle where all of the angles are the same, a rhombus has all of its sides the same, with 4 congruent sides. Now, normally when people are talking about rhombuses, they're talking about things that look like diamonds. Here, I can see that I have a parallelogram, and all of the sides are the same length. Here, I've got a parallelogram where all of the sides are the same length. This is a rhombus. This is a rhombus. Rhombuses are parallelograms where all the sides are the same length. The next one is tricky because it's a square. A square is a mix of rectangle and rhombus. Just because something is a rectangle doesn't mean it can't be a rhombus. Just because something is a rhombus doesn't mean it can't be a rectangle. If it's both of them, we call it a square. Because as we know, rectangles have to have all of their angles the same. And rhombuses have to have all their sides the same. In a square, both of those things are true. A square has all of its sides the same, which means it's a rhombus, and it also has all of its angles the same, which means it's a rectangle. So a square is actually a special kind of rectangle. It's also a special kind of rhombus. So that's a square. The last one we have to talk about is a trapezoid. And a trapezoid is not a parallelogram. A trapezoid is something totally different than a parallelogram. Whereas a parallelogram had 2 sets of parallel sides, a trapezoid has only 1 set of parallel sides. So, the easiest way for me to think about a trapezoid is to think about drawing a track. So I'm going to draw something that looks kind of like a pit falling in. If I draw this pit, we can see it's a quadrilateral because it has all 4 sides, but we can see that if I look at those, only the top and the bottom are parallel. The sides, if I were to keep drawing them, they would eventually intersect. That's not what I want. That wouldn't be a parallelogram. Only 1 set is parallel. We can also draw a trapezoid like this, where the small part is on top and the big part is on the bottom, or we can draw it on its side. We can draw it something like this. Here again, we see only 1 set of parallel sides. The other 2 would eventually intersect. This is a trapezoid. Trapezoids have only 1 set of parallel sides. All right, that was a lot of information. Let's see how those quadrilaterals interact. If you are drawing this into your math journal, here's what I would have you do. Draw in on your page 1 big giant rectangle, taking up the whole page. Everything inside this rectangle is a quadrilateral. Every single quadrilateral that ever exists in the whole world is going to fit inside here. Then we're going to split it up. We're going to split it up into a big circle up here and a smaller circle down here. you'll notice that those circles don't take up the whole quadrilaterals because there are things that are not in these circles. There are still some quadrilaterals that are not parallelograms. And there are still things that are quadrilaterals that are not trapezoids. Okay, before we go on to our next part, I want you to go ahead and I want you to put your finger inside parallelograms. Everything that's a parallelogram is inside this circle. Can you get down to where the trapezoids are? No, you can't get down to the trapezoids without leaving this circle. So you have to stay in this circle that be a parallelogram. If you can't ever get down into trapezoids, that means there's never a shape that's both a parallelogram and a trapezoid. If it's a parallelogram, it can't ever be a trapezoid. If it's a trapezoid, it can't ever be a parallelogram. Let's look at down here. If I put my finger in trapezoids, are you also inside the quadrilaterals? Yes. So every trapezoid is always a quadrilateral. No matter where I go in trapezoids, I'm always a quadrilateral because it's always inside the quadrilaterals box. But it's never a parallelogram because my finger never goes into the parallelogram circle. Now let's add our next part. Inside parallelograms, we have some special types of parallelograms. Inside parallelograms, we have two more parts. So it's going to look kind of like a Venn diagram inside your parallelograms. Inside the parallelograms, we have special kinds that are rectangles, and we have special kinds that are rhombuses. Rectangles, remember we said they have 4 angles the same. Rhombuses, we said they have the same sides. In the middle, we have squares. Okay, it just got a lot more complicated. But we can use this to figure out the relationships. If I put my finger in rectangles and I move it all the way around the rectangle circle, do you see how it's always still in parallelograms? That means that every rectangle is always a parallelogram. It has 2 names. You can either call it a rectangle or you can call it a parallelogram. Do you see how no matter where I move my finger in rectangles, it's always inside the quadrilaterals box? So every rectangle is always a quadrilateral. Do you see how sometimes the rectangle is a rhombus? Sometimes a rectangle can also be called a rhombus. Do you see how it never goes down into trapezoids? No matter how I move my finger in rectangles, it can never get down into the trapezoid circle. Using this graphic organizer, we can figure out the relationships of all sorts of different shapes. So I'm going to draw a shape here, and I want you to tell me all of the names for that shape. So put your finger in what kind of shape you think that is. I think that's a rhombus. Now I want you to look and I want you to say, what are the names for that shape? Well, I can't call it a trapezoid because I'm not in the trapezoid circle. I can't call it a square because it doesn't have all of its angles the same. And if I can't call it a square, then I can't call it a rectangle because it's already in the rhombus circle. But it's still in the parallelogram circle. So this is a rhombus and it's a parallelogram. And I'm still in the quadrilaterals box. So this is a rhombus and a parallelogram and a quadrilateral. All right, I hope that helped.